Imagine a world where reality is not what it seems, where the very fabric of existence is called into question by a simple yet profound thought experiment. This is the world of Erwin Schrödinger, the brilliant physicist who dared to challenge our understanding of reality with his famous cat paradox. In 1935, as Europe teetered on the brink of war, Schrödinger conjured up a mental image that would shake the foundations of science and philosophy. A cat trapped in a box, simultaneously alive and dead, its fate hanging in the balance until observed. But here's where it gets fascinating. This thought experiment was not just a morbid curiosity, but a cleverly crafted critique of the Copenhagen interpretation of quantum mechanics, which suggested that reality is undecided until observed. And this is the part most people miss. Schrödinger's cat was not just a paradox, but a catalyst for a deeper exploration of the nature of reality itself. To understand the significance of Schrödinger's cat, we need to delve into the life and work of this visionary physicist, who not only revolutionized our understanding of quantum mechanics, but also made groundbreaking contributions to biology and philosophy. Born in Vienna in 1887, Schrödinger was a child prodigy who excelled in mathematics and science from an early age. He studied under the likes of Friedrich Hasenöhrl and earned his doctorate in 1910 before serving in the Austrian army during World War I. The war had a profound impact on Schrödinger, who carried notebooks filled with equations even on the front lines. After the war, he returned to Vienna, where he became embroiled in the intellectual ferment of the city, frequenting coffee houses and lecture halls, and engaging with the likes of Sigmund Freud and Albert Einstein. But it was his work on wave mechanics that truly cemented his place in the annals of science. In 1926, while on a skiing holiday in the Swiss Alps, Schrödinger developed the wave equation that would explain the behavior of particles in terms of wave functions rather than fixed points. This breakthrough not only matched the results of Werner Heisenberg's matrix mechanics, but also provided a more intuitive understanding of the quantum world. Schrödinger's wave mechanics explained phenomena like the hydrogen atom's energy levels with breathtaking accuracy, earning him the 1933 Nobel Prize in Physics, shared with Paul Dirac. However, it was his thought experiment with the cat that truly sparked controversy and debate. By imagining a cat trapped in a box with a radioactive atom that could decay and release a poison, Schrödinger highlighted the absurdity of applying quantum rules to everyday objects. The cat, he argued, was both alive and dead until observed, a state of superposition that challenged our classical understanding of reality. But here's the thing, Schrödinger's cat was not just a thought experiment. It was a call to action, a challenge to scientists to question the assumptions of the Copenhagen interpretation and to explore the nature of reality more deeply. And this is where things get really interesting. Schrödinger's work on the cat paradox has been interpreted in many ways, with some arguing that it supports the idea of a multiverse, where every possibility exists in a separate universe, while others see it as a critique of the notion of observer effect, where the act of observation itself determines reality. But what do you think? Do you believe that reality is undecided until observed? Or is there a deeper, hidden truth that awaits our discovery? As we ponder these questions, we are reminded that Schrödinger's work extends far beyond the realm of physics. His 1944 book, What is Life?, proposed that genetic information might be stored in a molecular code script, an idea that would later inspire James Watson, Francis Crick, and Rosalind Franklin to discover the structure of DNA. Schrödinger's curiosity also led him to explore Eastern philosophy, where he found parallels between the ideas of unity and interconnectedness and the principles of quantum mechanics. His personal life, too, reflected his unconventional mind, as he lived with a second partner while married, a situation that was tolerated in academic circles but raised eyebrows in polite society. Today, Schrödinger's legacy extends far beyond the world of physics, influencing fields from quantum computing to science fiction. His name has become synonymous with the paradoxical and the unknown, a reminder that reality is stranger than we think, and that the truth awaits our observation. So what do you think? Are you ready to embrace the uncertainty principle and explore the strange and fascinating world of quantum mechanics? Or do you have a different take on the nature of reality? Let us know in the comments below.